So in today's video, we're going to look at finding the equation of a normal. And if you don't know what a normal is, don't worry. I'm going to go through what a normal is, and we'll find the equation of a normal to this curve, y equals x squared minus 4x plus 5. And we're going to do it at a particular point, so when x equals 3. So our first step is to draw the graph. So if we have a look at this curve, it's actually going to be above the x-axis. Okay, so what we're going to do is find the axis of symmetry, and I'll show you how we do that and how that's going to help us graph this curve. So the formula for axis of symmetry is just this one. So it's x equals minus b over 2a. You've probably seen this one before. And our minus b is just this number here. So it's minus 4. It's the coefficient of the x value there. So that's actually going to be 4 because it's minus b. And then it's over 2a. And the a value is the coefficient of the x squared. And in this case, it's just 1. So that's just going to be, 2 there. And that means that our x value is 2. Okay, so our x value for the axis of symmetry is going to be 2. So I'll just show you where that's going to be. It's going to be somewhere there. Okay, so somewhere on the x value 2. To find the corresponding y coordinate, we have to substitute x equals 2 into the original formula. Okay, so I'll just do that. I'll do it over here. It's going to be something like this. So y equals 2 squared is 4, and then we've got minus 8, and then plus 5. Okay, so I've just swapped an x, all of these x's with a 2, and that's what we get. And that's going to be 4 minus 8 is minus 4 plus 5 is going to be 1. Okay, so that means that the axis of symmetry, the vertex here for this parabola, this one is a parabola, is going to be right there. It's going to go through the point 2, 1. Okay, so what I'm going to do is just draw that curve now. And you can see the y coordinate, the y-intercept is going to be plus 5, which is going to be off our axis, but that's fine. It's going to look something like this. Okay, that's all right. Okay, so there's our graph, and we're looking at the equation of the normal at the point that x equals 3. Okay, so what we can do is just draw that. So x equals 3 is just there, so it's going to be somewhere around about here. Okay, so that's the point that x equals 3, and I might even just find the y coordinate for that now. So I'll do that. Let's do that down here. So that's going to be y equals 9 minus 12 and then plus 5. Okay, so I've just substituted x equals 3 into that original formula there. And that's going to give me minus 3 plus 5 is going to be 2. Okay, and you can see from the graph, it's roughly there. Okay, so there's our point. And let's have a look now at the normal. So the tangent, first of all, we've looked at that in a couple of previous videos. The tangent is going to look something like this. It's going to go through, and it's going to just touch the curve at one spot right there. Okay. Now the normal is the line that is perpendicular to the tangent. Okay. So the normal is actually going to look something like this. Okay. So it's going to come out at a right angle. So that's going to be a right angle. It's going to come out at a right angle to the tangent there. Okay. And that's important because we'll see why in a second. Okay. So now we're going to look at finding the equation of the normal. So our first step is to differentiate the curve. Okay, so we're going to use some calculus now. So it's, oh, sorry, made a mistake there. I'm going to fix that. Okay, so I'm going to differentiate the curve. So the derivative is going to be 2x and then minus 4. Okay, so that's our derivative. And now what we need to do is find the value of that at the point x equals 3. So when x equals 3, the derivative is going to equal 6 minus 4, which is just going to be 2. Okay. Now, this is going to give us, if we substitute this into our formula, and I'll just write this up actually. Okay, so this is the formula that we're going to use to find the equation of the normal. Okay, so y minus y1 equals mx minus x1. Okay, so this is the formula that gives us the equation of a line. Okay. And what we need to do is find m, which is the gradient, and then we need 2 points. Sorry, just 1 point. And we need a y value and then an x value for that. Okay, so we've got a gradient here. Okay, so we've got 2, but this is going to give us the equation of the tangent. We want the equation of the normal. Okay, so to find the equation of the normal, what you need to do is find a value that you multiply this by to get -1. okay? And that's going to give you the gradient for the normal, okay? So I'll just show you what that's going to look like. So we're going to multiply 2 by something, okay? Something's going to go here, and it's going to equal -1, okay? So that's the gradient of the tangent, and we need a number here to get -1. The answer is going to be -1/2, okay? So 2 times -1/2 is going to equal -1. And so that's going to be our value for m, okay? Because that'll give us the equation for this one, okay, the normal. So let's do that. So let's go y minus, and we've got our y value, which is 2. We worked that out earlier. I might even just put this up here. So it's going to be 3 and then 2. Okay, that's that coordinate just there. So it's going to be y minus 2 equals, and here's where we put our gradient for the normal. It's going to be -1/2. And then we do x, and then we put our x value, which is 3. So x minus 3, like that. Okay, so now we can just evaluate this. So we can multiply both sides of the equation by -2. I think that's probably the best way to go. So we'll go -2y, and then +4 is going to equal x minus 3. Okay, so now we can go -2y equals x, and then we're going to go -7, and then y is going to equal -x/2, and that's going to be +7/2. Okay, and that's it. Okay, so that's our equation of the normal. So y equals -x/2 +7/2. Okay, so you can see it's a little bit more complicated than the equation of the tangent, but yeah, if you just go through this process, you should be able to find the equation of the normal to any curve at the point that you're after.